All right, section 8.3, and we're going to talk about a couple special type of triangles. As my grandmother would say, they're spatial. That's how she used to say it. That's so spatial, because she's from West Virginia. That's why she talked like that. Yeah, they probably talk like that too, didn't they? I remember my grandmother, my sister, we were at a family reunion, and my grandmother says, "Hey, come over here, Aaron. Go in the car and grab me that poke and bring it over to me." I'm like, "Okay." So I go over to the car. I was like, I have no idea what a poke is. I was like, I figured I'd look in the car and see something that looked like a poke. I don't know. I didn't know that, but yeah, that's exactly what it was. And I was like, I'm looking around like, oh, I don't want to go back. I'm too embarrassed to ask my grandmother what a poke is. So my little sister, who's like 4 or 5 years younger than I am, and I was probably middle school, so she was like a little girl. And I said, "Annette, come here. What's a poke?" And she says, "I don't know." And so, "Go ask Mom." And so I had my little sister go ask my mom what a poke is, and they started cracking up. And of course, just like any parent, they tell everybody at the reunion, "Oh, my kid went over there and they didn't know what a poke was." And, I was like, "Oh, thanks a lot." I was trying to keep this quiet so I wouldn't embarrass myself. Now everybody knows. So, but yeah, it was a bag. It was a paper bag. And I'd never heard. Has anybody heard that? I guess you heard it, right? You just thought of it?
Was talking the same thing. They were telling us that.
Are you serious?
Yeah.
That's funny. Well, anyway, that's my grandmother's. That's my grandmother's story.
And they call Coke pop or something.
Yeah. Well, that's a lot of Midwest. Midwest says pop a lot, and down south. No, I don't think I told you that. In the South, yeah, they say that all the time.
I don't think any other teacher would tell me that except you.
I'm telling you, I've never told a pop story. I don't ever remember telling that. All right, here's a special type of triangle, or a spatial type of triangle. Here we go. This. Actually, I could have done this. I could have said it's isosceles, right? So what are the angles then if it's isosceles? They both have to be 45 degrees. All right? Now, this is a special type of triangle where you're going to have to memorize a couple things. You guys are watching, right? This is important stuff. We're going to be using this a lot, a whole lot. So I want you to make sure that you're clear on what we're doing here. It's an isosceles triangle. It's a 45, 45, 90 triangle. That's what we call it. Okay? We call it 45, 45, 90 triangle. I don't know, some people might call it 45, 45 right triangle, but I just say 45, 45, 90 triangle. You got a couple legs and you got a hypotenuse, okay? So we'll call this L for leg. We'll call this L for leg, and guess what we'll call this? How about H for hypotenuse, okay? What we're going to do, there is a special relationship between the hypotenuse and the legs of a 45, 45, 90 triangle. And I'll show you how we get to this on the 45, 45. On the 30, 60, 90, I'll just tell you what it is. But on this one, we'll do some work. So watch this. If I wanted to do some kind of relationship here, let's solve for h. I'm not putting any numbers in at all. Okay, all I'm doing is solving for h. So we just talked about Pythagorean theorem. So let's do that and get h by itself. So what would we get? We would get h squared equals. What do you think? Yeah, we'll do it one at a time though, but you're absolutely right. It's going to be 2l squared. So watch. H squared equals, what's 1l squared plus 1l squared? 2 what? L squared. Now let's do this. Again, we're trying to solve for h. If I want to solve for h, what do? Square root, right? We've been doing that all along, haven't we? We did that with geometric mean. We did that with Pythagorean theorem, so that shouldn't be new to you. So that gives you h. Now look what we get. We get the look at this thing right there. What's the square root of L squared? It's just L. Square root of 2 is just the square root of 2. So watch how I'm going to write this. This is really important right there. That's what I was getting at right there. That the hypotenuse is equal to, guess what? The square root of 2 times the legs. You say, well, big deal. Who cares? Well, it makes things a lot easier for you, I promise. So if you had a 45, 45 triangle, and let's get a different color here, and you knew this was 5. Now, Travis, here's a situation. Remember you said if you just know one side, can you find the other? Well, actually, you know two sides because you know these two are equal. But let's just say you knew this one right here. And we'll do one where you know the hypotenuse and you don't know the other sides. So this is a situation where you will be able to find the other sides knowing just the hypotenuse. But that's only true so far on a 45, 45, 90 triangle. You can't do that with every single triangle. Okay. So anyway, if this is 5, look at the hypotenuse. What's the relationship between the hypotenuse and the legs? The hypotenuse is equal to what? The square root of 2 times what? One of the legs. Do you agree? We just figured that out. So look, without really doing any math at all, what do you think the hypotenuse is equal to?
What's the x?
Times. I said times. I said square root of 2 times one of the legs. All right? If you want, I can make it a big old dot. Okay? Is that better? Okay. Square root of 2 times one of the legs. Or you just put it next to each other. I don't know. I just did that. So what would this be? Somebody tell me. Caitlin, what did you say? Is it square root of 10? Remember, it's the square root of 2 times one of the legs. So it's the square root of 2 times what? 5. But we don't write square root of 2 times 5. What's a better way to write that? Yeah, put the whole number out in front. So this would be what? 5 square root of 2. We can't multiply those together because the 5 is not under a square root. If it was, it would be the square root of 10. Right? So if this was the square root of 5, yeah, this would be the square root of 10. All right? Does that make any sense? So that makes it really actually pretty easy. What would this side down here be? It would be 5 because 45, 45 means it's an isosceles triangle. If this is 5, then this is 5. We good with that? Look, we could do that with all kinds of things. Let's throw a couple other numbers in here. And then we'll do the hypotenuse. Say what? This only works on a 45, 45, 90. All right? So that's why it's special. All right, because it only works under certain circumstances. So it only works when you have a 45, 45, 90 triangle. So if I have an isosceles right triangle, that's a 45, 45, 90, isn't it? All right. Let's put another number in here. Let's say this is the square root of 3. So if this is a square root of 3, without doing any math at all, what's this bottom one going to be? That's going to be the square root of 3. So that's pretty easy. All right. But what's the relationship between the hypotenuse and the legs? I take the leg and do what to it? Multiply it by the square root of 2. Are you following on this formula? Does that make sense at all to you? The hypotenuse is equal to, so if I wanted to find the hypotenuse, this one right here, I take the leg and I multiply it by the square root of 2. Well, I know the leg, don't I? It's the square root of 3. What's the square root of 3 times the square root of 2? Square root of 6. That's it, without doing any Pythagorean theorem. Now, if you wanted to, you could do Pythagorean theorem, couldn't you? To figure out what this is, because you know two sides of a right triangle. If you wanted to, you could do that. But you don't have to, because it's a special circumstance, a special triangle, kind of like those triples, right? Those Pythagorean triples. It just makes it a little bit easier. And I'm all for what makes it easier, aren't you? Yeah, I definitely am. So this is a little easier, but you got to realize something. You got to understand that relationship between the hypotenuse and the legs. If you understand that relationship, then you're good to go. Does that make sense? What if I had, I don't know, 2 square root of 7? What would this side right here be? Right, that's easy. 2 square root of 7. What would this one be right here, the hypotenuse? Very good. It's 2 square root of 7, the leg, times the square root of 2. All we do is take the leg and multiply it by square root of 2. So if I took this thing and multiplied it by square root of 2, it's 2 times the square root of what? 14, because square root of 7 times the square root of 2 is the square root of 14. Think you can handle that? All right, what if we did it the other way? Travis asked earlier, what if we had a right triangle and we only knew the hypotenuse? Could we find the other two sides? Well, in this situation, in this one special particular situation, yeah, we could do it. I'm going to make this actually kind of easy. What if I call this 5 square root of 2? Let's think about this. What's the relationship? The hypotenuse, if I take the leg and multiply it by the square root of 2, Jacob, you're with me? Okay, you sure you're getting all this? If I take this side right here and multiply it by square root of 2, I get this. So what do you think this is right here? Just 5, isn't it? Make sense? So if I take this and multiply it by square root of 2, I get 5 square root of 2. So this had to be a 5 to begin with. What's another way to do this? Whoops. What am I doing? That's right. You could plug it in. Let's do that. Okay? Because look, we know the hypotenuse, don't we? Let's plug it into this. So 5 square root of 2 equals what? Square root of 2 times the leg. That's what we're trying to find. So that's right. How do I get the leg by itself? Divide by the square root of 2. Do you see that? And so watch. That cancels with that. What's the leg equal to? It's just 5. All right? It's not hard, is it? So if we know the leg, what do we do to get the hypotenuse? We multiply it by square root of 2. If I know the hypotenuse, what do we do to get to the leg? I divide by the square root of 2. You get it? Because look, if I wanted to, I could write it like this. If I wanted to get L by itself, what's L equal to? It's H divided by the square root of 2. Agreed? All right, so you could go either way. Let's make it a little bit trickier. What if I said that the hypotenuse was 7? How do we find the leg? That's right. To find the leg, what do? We take the hypotenuse and do what to it? We divide it by the square root of 2. So it's 7 divided by the square root of 2. But do we leave our answer like this? Why not? What's wrong with this? It looks fine to me. You can't simplify square root of 2. Exactly right. You can't have a square root in the denominator. Okay? For some reason, remember we talked about this, somebody somewhere made up a rule that said we're not supposed to have a square root in the denominator. If you talk to Mr. Jackson, you know, at the point where he is in teaching, you know, calculus and stuff like that, he's like, I don't care if you have a square root in the denominator. It's not that big of a deal. But I had a discussion with him the other day about this. We think it's a good idea for you to teach this, for me to teach this, and for you to understand how to get rid of that square root, because you will have situations on different tests, standardized tests. I know Math League, you got to make sure that your answer is in simplest form. In a Math League question, if this was your answer, they wouldn't let you keep it like this. They would want you to simplify it. I know in some, I don't know, some other classes, high school, college, whatever, some people will not allow you to write your answer like this, and they'll mark it wrong. So I want to make sure that you know how to do this. So how do we do this? Multiply the top and bottom by the square root of 2. We've gone over this before, so I'm going kind of quick here. Why do we do that? Because what is that thing? What's anything over itself? It's just a 1, isn't it? All right, I'm allowed to multiply anything by a 1. It doesn't change the value of it. So look what I get. On the top, I get 7 square root of 2. On the bottom, what do I get when I multiply those? It's just a plain old 2. No, square root of 2 times square root of 2. The bottom. Square root of 2 times square root of 2 is the square root of 4, which is 2. So that would be my answer. So this side right here would be 7 square root of 2 over 2. What would this side right here be? Same exact thing. Make sense? That's about the hardest that it gets, this 45, 45, 90, is when the hypotenuse is a whole number. And now you know how to do it. Right? You just take this and you divide it by the square root of 2. And then you simplify it and you get this. So these are your 2 legs. Make sense? All right. Let's go on to one more special type of triangle. So remember this. This is 45, 45, 90. And the hypotenuse is equal to the square root of 2 times one of the legs. See, this is right here. That's very, very important. Make sure that you know that. Okay, write it down somewhere. That the hypotenuse is the square root of 2 times one of the legs. It's only one relationship we really need to know. Well, there's another triangle. This time there's going to be 2 things you need to know. Let's make it look a little more like this. Now this is definitely not 45, 45 because these 2 legs are not equal to each other. Agreed? Okay, but this is a special type of triangle. This is a 30 degree. If that's 30 and this is 90, what's this one have to be up here? It's got to be 60. That's right. So guess what we call this one? 30. Let's go in order. 60 what? 90 triangle. So this is our second special triangle. And there's a couple things that we know about this. Now I'm not going to go through and show you why or prove it to you. It can be proven. But I'm just not going to take the time because we're running out on time right now. But I will show you the relationships between the sides and all that kind of stuff. Well, look at this. This side right here that's opposite the right angle. What do we call this side right here? The hypotenuse. So just call it H for hypotenuse. Well, it's just HYP. Is that all right? Now, what we're going to do, look at this side right here. Is that side bigger or smaller than the other leg? It's smaller. Now, how do you know? Not just by looking at it, But by doing what?
The angle across.
By the angle across from it. Very good. Okay, this is opposite the smallest angle, so it's the smallest side. Okay, the hypotenuse is always the largest angle because it's always the opposite the largest side on a right triangle. Or sorry, it's opposite the right angle or the largest angle in a right triangle. You follow me? So this one would be like the middle one. Okay, but what I do is I call this, what do I call it? It's not the small. Oh, the short. Yeah, my goodness. For some reason I had small in my head, but I've taught this for many, many years, and I forgot that word. This is called the short side, and I call this the long or the longer side, or the longer leg, the long leg if you want. Okay, we'll just call it the long leg. Is that all right? Remember, the hypotenuse is the longest side, isn't it? All right, but the longer side, or the longest leg, the long leg, we'll call that one right there. How do you know? Because it's opposite 60. How do you know that's the shortest one? Because it's opposite 30. Okay, let me just show you just a couple relationships here. And the short one, it all centers around the short one. Okay, the short one is the important one.
Is the vertical angle
Vertical?
the short one,
What do you mean the vertical angle?
or the vertical side?
The short one?
Side, is
Short
that
side.
1/2 of the long side?
No. But it is 1/2 of something else. Okay, and that's the first thing we're going to do. Watch this. Everything relates to the short side. So first thing I'm going to do is I'm going to talk about the hypotenuse. There's a relationship between the hypotenuse and the short side. Let me show you. The hypotenuse is exactly twice, I'll put a dot, the short side. Okay? It's twice as long. So the hypotenuse, not the longer one, the hypotenuse is exactly twice as big as the shorter side if you have 30, 60, 90. Okay? Jacob? Head up. It's 2 strikes. Look at the other one. Are we okay with that? So what if the short side was 3? What's the hypotenuse? 6. Okay? What if the hypotenuse was 20? What's the short side? It's 10. What if the hypotenuse was 7? What's the short side? What's the short side? The short side's 14 if the hypotenuse is 7. It's 3.5, 3.5, right? 7 over 2. That's what I would do. I would put 7 over 2. Make sense? So if you know the hypotenuse, you take half of it to get the short side. If you know the short side, you do what? Yeah, you double it. You multiply by 2 to get the hypotenuse. That's a very simple, easy relationship. Would you agree? Okay. Now, the next relationship, again, what did I say? It's all about the short side. They both relate to the short side. So I'm going to take the longer side, or the longer leg. Now, the number 2, it's the square root of 4, isn't it? Okay, this is how I remember it. It's just kind of a little device that I remember. The longer leg is just a little bit shorter than the hypotenuse. It's not quite twice as big as the short side. So it's not quite the square root of 4 times the short side. It's just a little bit smaller. What do you think is just a little bit smaller than the square root of 4? Square root of 3. Exactly. That's how I think of it. Okay, that's how I try to remember it. So this is actually the square root of 3 times the short side. Now there is a proof for it on how you get to that. We're not going to do that right now. Okay, I'm just showing you what the relationships are. And there you go. That's 2 things to remember on a 30, 60, 90. Remember, the hypotenuse is twice as big as the short side. The longer side is what? It's not twice as big. It's not the square root of 4 times as big. What is it? It's the square root of 3 times as big as the short side. So the easiest version of this problem is when they give you the short side. Let me get rid of this. We're almost done, so just bear with me here. Watch. What if they give you this was, I don't know, 5? That's the easiest. If they give you the short side, that's the easiest way to do this. If this is 5, what's the hypotenuse? It's 10. You just double it. Look, this is almost easier. A lot of people freak out when they see the square root of 3. This is actually easier because I don't even have to do any arithmetic. Right here, I had to know what 5 times 2 was. I mean, not that that's hard, but you still had to know it, didn't you? Look at this. If I know the short side, what's this? It's just 5 square root of 3. I really didn't have to do any math at all, did I? All right, that's pretty cool, isn't it? All right, let's do another one. What if I knew that this was, We'll go 7. All right, make it a little bit tougher. This is 7. What's the easiest one to find? Well, you can't even go right to the long side. Do we have a relationship between the hypotenuse and the long side? No. We got to go to the short side. The short side's the important one. So if I know this is 7, what's this? Yeah, what did I say to make it? Yeah, make it 7 over 2. It's a lot easier, I promise you, okay? Don't be afraid of fractions. 7 over 2. If you put 3.5, would I mark it wrong? No, I wouldn't, okay? It's fine. But for what we're going to do now, I think it's easier to write 7 over 2. Now, how do I find this one right here? Yes, 7 over 2 times the square root of 3, but when we do square roots and stuff, it's a lot better to write it like this. 7 square root of 3 over 2. Do you see that? It's 7 halves, 7 over 2, times the square root of 3. But that's just a little bit more concise. It's a little bit more acceptable, I guess, to write it like this. Okay? So that's not hard, is it? If you know the hypotenuse, it's easy to find the short side. If you know the short side, it's easy to find the hypotenuse. If I know the short side, the long side's easy. Here's the part where it gets a little bit tricky, is when they tell you the long side. So if they told you the long side was 10, we can't find the hypotenuse. There's no relationship between those. How do we find this?
10.
That's right. It's 10 divided by what? Square root of 3. Simplify it would be, you can do this on your own, 10 square root of 3 over 3. If this is 10 square root of 3 over 3, what do I do to find this one right here? Double it. So that's what? 20 square root of 3 over 3. Let me give you some problems to do. Because you need to practice this stuff. Here we go. It's page 556, 557. And we're doing 8 to 25. There you go. Section 8.3. Section 8.3.